Okay. Okay. Good morning, everyone. I should just quick. I need to quick. Okay. Just. Yeah. Okay. Sorry. So let's start. So welcome to Ccamp session. So I think you can get the meeting information, including the meeting slides from the link below. And also you can get more information about Ccamp from the tools page. So this is the Noteware, and this is the new version of the Noteware. I think all of you should be very familiar with this kind of information, because each working group needs to introduce the Noteware before presentation. So actually, this Noteware mainly about IETF policies, especially IPR policy, and the definition of IETF contribution and participation. So if there are some newcomers, please take a look. So as usual, we have the audio recording. So please speak in front of the mic and state your name before speaking. And for the minutes, so our secretary Oscar, he's not here. He's quite busy. So if anyone can capture some minutes and capture the discussion of this session, we appreciate. Thank you. Jambo room, there are some people in the Jambo room. I think we will keep an eye on the Jambo room. If there are some comments from the Jambo room, I think we can raise the comments in front of the mic. So this time we have two sessions for Ccamp. Right now, this one is session 2. So this is the agenda. So I think this time we have more time. We have 2.5 hours. So we should have more time for discussion. So please just take your time as requested. Any comments on the agenda? Okay, none. So a reminder for the IPR process. Usually we will do the IPR polling before an individual draft becomes a working group document, or a working group document goes to WG last call. And usually we hope the authors and the contributors to reply the IPR polling as soon as possible, and then we can speed up the working group process. Another reminder on the mailing list, we always encourage people to use the mailing list as much as possible. Any technical issues, technical problems can be or should be discussed on the list. And also, that working group consensus is determined on the mailing list, not by the face-to-face physical meeting. Even though if we get some consensus here, we should bring it to the list for discussion. Okay.
So there are quite a lot of progresses since last meeting. We have a new RFC. Finally, we have put this document on hold for a while, waiting for the generalized extensions to be done in TIS. The working thesis is concluded, and we could progress the SPF availability extension in Ccamp, which now made it, and it's now RFC 8380. We have one more document in the editor queue. This is another document that was depending on the generalized SCSI document. And two documents, the microwave framework and the DWDM interface management framework. Both of them have been submitted to the ASG, and they are now in the expert review phase. Working group drafts on agenda. You will see a new draft, the Transport MBI applicability statement. This is a merge of the existing working group draft produced by the Transport MBI, plus the analysis of use cases 1 and 3. Please, Ethan, and correct me if I'm wrong. And the microwave of Young. Working group drafts, which are not being presented today, are the Ccamp LR module, which has been adopted recently. It received a lot of comments on the mailing list. There's a lot of good discussion on it, and also we received a liaison from IETF study group 15 on that. Recently, we adopted also the FlexiGrid Young model. About the other ones, there is no update on the OTN topology and the OTN tunnel model. I don't know if any of the authors would like to say a few words about the status and the progress of the OTN drafts.
Yeah, I'm from Huawei, and I'm taking care of the OTN topology and the tunnel Young models. And this model is supposed to have the augmentation from the generic T models in T's working group. And currently we notice there are some changes on the fundamental model, but we hold on for this model update to make sure that after the maturity of the T models, we can update accordingly. We are now working together with the T model authors to make everything consistent.
Thanks a lot. Another one that has been recently adopted is the WSON tunnel model, WSON Young, and yesterday we adopted also the WSON impairment aware encoding. Liaisons, we have, as usual, a quite intense communication relationship with the ITU, study group 15. We sent a liaison on the Yang LR module, as I said before, and the reply was an incoming reply is available on the web page for you to read and comment. This is it for the introduction. We can start with the first presentation. Any comment on the agenda? Everything is fine with it?
Thank you. I'm Italo Busi from Huawei, giving an update about the Transport MBI design team. So, quick reminder about what is the objective of the design team is to develop some use cases and gap analysis to understand how the IETF Young model can be applied to transport network, and coordinate with Ccamp and Ts if any changes needed to fit into the applicability. And what we do, we have a mailing list conference calls, and we have a GitHub where we track the changes, the editorials, the work, and the open issues. What we have done, as already summarized quickly by Daniele, we have a new draft, which is a Transport MBI applicability statements, which is basically merging the three documents, the working group document, the two individual documents we produced in the past. And this is basically focused on analyzing the Young models that can be used to control a multi-domain OTN networks. We provide some JSON code examples to see how in this specific use case the different fields are filled. And basically, we focus on the MPI between MDSC and multiple PNCs, and we work about what is the topology abstraction, how to set up the service end-to-end across a multi-domain network, how we can configure protection and restoration, and we have recently added the possibility to modify the service from protected and unprotected, modify the bandwidth. We have some open issues which we are working on. The first open issue was raised also on Monday during the TIS working group. It's the relationship between this work, our work, and the T tutorial. We had some discussion yesterday with the authors, and we have understood that the objective of the two work are quite different. So T tutorial is mainly focusing on describing the principle, the definitions, and the modeling assumptions for the T topology and tunnel models. And the use cases developed in that document are mainly to explain based on demand. People say, how do you do this case? Then they show how to do that. And they also cover maybe also some advanced topic like detailed connectivity metrics and constrained path computation, how you do this advanced stuff. Our work is more focused on the specific use case, which is multi-domain OTN. We work on that, and we want to show how you can, in a multi-domain OTN network, configure services end-to-end, and maybe some items like the connectivity metrics or constraints path computation. We don't go into that details. We go more on the details on how the different domains are coordinated. So there is, of course, there are different objectives. There is some overlapping, and the idea is that the authors of the two drafts work together as already done, and trying to avoid inconsistency. Some duplication may be unavoidable, especially on the JSON code, but we will make sure that there is no inconsistency. That's the most important thing. And people may be interested in two different approaches, so it's good to have both. So that's the proposal from the authors of the two documents. The second open issue is what to do about our work. So do we need to coordinate or communicate with other projects like OpenConfig, OpenRODAM, TIP, and MEF? I think, again, we forgot ONF as well. But okay, yes, if there are other people and we want to see whether we have to work together and make sure that the use cases are covered.
I would say, I would like to try to answer your question. In an ideal world, yes, but
yes.
I cannot understand it's almost impossible to do everything. So
Okay.
Try to focus on our original scope, which was mostly main activities.
Yeah. We are focused on developing the use case, but yeah, the question is, do we want to look at say?
If you have time, that's
Yes,
more than
okay.
appreciated. But
Okay, I see.
I'm not asking you to do that much.
Clear. Okay, thank you. Good input. The other open issue is we got some input about the multi-layer city architecture. It seems that when you have an hierarchy, a different hierarchy between underlying technologies, some information may not be available to the top level MDSC. We had some discussion, but we have not finished to analyze that. One doubt is whether this is an issue that applies only to packet and optical multi-layer, or it's a general applicable, for example, to OTN layer 0, layer 1. So we are trying to understand, because the major issue is the fact that the main boundaries between IP and optical do not match. So you may have a different abstraction hierarchy, and the guys who have to coordinate the two may not have enough information if you abstract too much. So we are still analyzing to validate the concern if there is a solution and to describe it. But the doubt is whether it is generic, applicable to our case or not. We still don't know. We are still working on that. We have some discussion on the client services. So the big issue is that the T-tunnel creates a tunnel between the end nodes, but we need to configure how the access traffic, for example, internet access traffic, is classified and is mapped into the T-tunnel. And we are working assumptions to use the models that will be presented by Aumian later in the agenda. But okay, that's something we have to analyze in the next phase. And then we have some minor detailed technical discussion, like how the I2RS identifiers and the TST identifiers match together. And somebody brought the idea to think about also what happens when you have ODUCN in the network. So we have to think about that, yeah. Okay, so next steps is to progress to addressing the open technical issue, to integrate the JSON example and provide more JSON example. We have a doubt, do we want to do any informal or liaison to ask people to take a look to our document and give feedback, and then we plan to have a face-to-face meeting basically this afternoon at 3:20. We will meet by the registration, IETF registration desk, and we look for a slot.
Okay, so regarding the liaison, well, the IETF has a formal liaison relationship with some of the bodies that you've listed. I don't see any issue in preparing a liaison and sending it out. Mostly now that the draft is a working group document. So if you want to try to propose a text on the mailing list, we can discuss it and and send it. We will then try to understand who to send it. Yeah. Okay, any comments? We are still warming up.
Okay, yes.
Hi, I'm Jonas Ahlberg. I'm going to present the status of the young data model for microwave radio link. Since the Singapore meeting, we have submitted 2 new revisions. The first one, the 03 revision, contains updates in order to align better to the IETF documentation guidelines. And we have looked at the 4 RFC in the sub-bullets listed on the slide here. Secondly, we have simplified some of the names of the data nodes, where we have removed a duplication of the group or container name also in the data node names. And finally, we have added a couple of examples at the end of the draft to explain how to instantiate 2 typical configurations in the radio link domain. One configuration called 1+0, that means that we have 1 radio link terminal containing 1 carrier termination interface. And the second one is a bonded configuration where 2 carrier termination interfaces are included in 1 radio link terminal. The second update since the Singapore meeting is based on valuable comments that we have received from Tom Patch. And we have added missing references and done some editorial corrections based on that feedback. So looking at the simplification of the names, it's fairly straightforward. If you can see on the left-hand side, that's the original model. And with the duplication of the container name also in the data node names. So we have removed protection, XPIC, and MIMO words that we believe are not necessary. And then ending up with the data model that you can see on the right-hand side. And this is how we have created the examples. This is the example of showing the 1+0 configuration. So we use a picture or a figure to illustrate the configuration as such. And this figure is showing both ends of a radio link, which is terminated by the radio link termination or terminal. And then in this example, it contains 1 carrier termination. And the actual instantiation is then shown for the near end, one of the ends of this radio link. So here we show one instantiation of the interface of type radio link terminal and the associated interface of type carrier termination. And way forward, we believe that the model definition is complete and it has been stable for some time. We have one comment though that I would like to get your input on, and that is a suggestion from Tom to break out the enumerations or the type definitions and put that into a separate module. And I would like to have your input on that, if that's the way to do it, or if we should keep it within the same single module. Otherwise, we would like to ask for a work group last call again. Thank you.
Comments, mostly on the last question.
Amy from Huawei. So regarding the last question, my personal preference maybe to break it out. I think that makes the models to be clear, and so it's easy to update each individual module, so it won't affect another one. So.
Tom Petch. Good afternoon, good morning. Yes, it's just based on experience, particularly with MIBs and to a lesser extent with Yang, that what starts off as one piece then turns into two separate pieces with two different life cycles. And so looking at the long, long list of QAM in particular, I don't know, I'm sure you know much better than I, whether that list is likely to change or not. And if there are new ones coming along, 64s, 128s, 256s, and so on, then it would make sense to break out that list. And if you look back, you'll see that's quite commonly been done with MIB modules, and it's also been done with things like interfaces, interface types, where the interface types have been separated out, because the expectation is that over the next few years, the life cycle of interface types will be different to the life cycle of the interface Yang module. And there are a number of examples of that already. Systems got it as well. So it's a rather belated thought. I mean, quite a bit of work for the editors, I'm afraid. But if you think over the next few years that list of, e.g. QAM, is going to change, then I would urge you to consider separating it out into a separate Yang module with a different life cycle.
Okay, thanks.
Well, when you speak about the different life cycles, are you suggesting to split the two modules into different drafts?
That's what they do with interfaces. I mean, and there's an ultimate separation where in the case of MIB modules, quite a lot of the enumerations were put under the control of IANA and put under expert review. And so you didn't even have to cycle an RFC in order to add new interface types to the list of interfaces. In this case, it would be to the list of modulation techniques. And so the ultimate would be given under IANA control with expert review. The most tightly coupled is what we've got at the moment with a single module. So if either part of that information changes, we have to recycle the RFC or put in something that augments it or whatever. So there's a spectrum of possibilities, and two Yang modules within the one RFC is the simplest separation.
Okay.
But it, as I say, it all depends on what you think is going to happen to that list. My experience is people think lists are stable, and then 5 years later find they weren't and wish they hadn't built it all into the same piece of concrete.
Okay.
Amy again, Tom, I have another questions. When you mentioned about this case, if the emissions won't be changing in a few years, I would like to ask how many is the few years? Maybe 3 or 5 years or longer than that. So we should, based on what kind of numbers we should make this decision.
Tom Betch again. I'm saying that I don't know what the likely life cycle of that list is. And I think your expertise in this room is far greater than mine. So if you think that list has been stable for 10 years, never going to change, then there's no point in doing anything. But if you think a new one's going to come down the road, and they usually come down the road, in my experience, much quicker than I expect. If you think a new one's going to come down the road, then it's worth, at least in my judgment, separating it out into two Yang modules within the one RFC to make them easier to update.
Yeah, it's hard to predict what's going to happen from a technology point of view, but to say that it's going to be stable for 10 years, no, I don't think we can say that.
Amy again. I agree with Jonas. Maybe 10 years. That's no, we won't. We are not able to say that. But I could say maybe 3 years. They will keep on changes. But I still prefer to split. But we will keep the modules within one draft. So it's easy. Not we could update and keep them because they are so coordinated with each other. So that's my suggestion.
So I'll tell you what we have not yet discussed about this. So it's just my opinion, not ours. This is so we've been working on young models for a while now, and I would like to have something published. And this is the only module that has no dependencies on ongoing drafts. All the tunnel topology models depend on publication of other documents. This one is based on an RFC. So this is the one that we can progress. If you feel that there is a number of parameters, a portion of the module that is stable and is not going to change, we can split the document and progress just that one. I would say to go this way if that amount of parameters is something that can be implemented. If it's something that standalone doesn't make much sense, it's pointless to progress just a subset of parameters that is useless in the end. If if this split makes sense, we can do it and progress one document. If the split doesn't make sense, then we need to discuss how to manage this. But again, just my personal inclination is to try to progress this document before the next meeting. So now it's the microwave experts that need to understand if there is a set of stable parameters that we can progress and leave the other part like work in progress or keep everything together. And possibly move everything together. If you believe that things are not going to change significantly, we can keep everything together and move everything together.
The way I don't believe that it's possible to split it into two parts, where one part is stable and the other one is more likely to change. The parameters or the enumerations we're talking about are key to the model, so we cannot break out any of them and say that we take care of them later on. They are core for the model as it is. Secondly, we have defined them as identities with the purpose to make it easy to extend them with additional modules or vendor-specific models if needed. I don't know if that helps or...
Well, it seems to be the good basis to address Tom's concern, in the sense that the module is quite future-proof, if I got to understand what you're saying. So this would make me think that keeping things together shouldn't be a problem. If with a single short document you can augment it easily.
Amy again. So I think even if we split into two modules, I don't think that's a significant change because it's more like a structure rearrange. The definition will keep the same. The technique, we don't change any technical part. So, but I will be fine with either way if there's more suggestions to keep them together. And I personally would like to progress. That's more important.
Tom, your last word?
Tom Petch. Most of my life, I seem to be encountering people who come up to me and say, Tom, we wish we'd listened to you 5 years ago and done what you suggested. I have the art of seeing the right answer, but being unable to persuade people it is the right answer. So I would say split out that list of identities into a separate Yang module. Keep it in the RFC, but split it into a separate Yang module. That's what I would do. Urge you to do.
Thanks.
Okay, thanks.
Hi, this is Amy Ye from Huawei, and I'm going to present about a new draft. We defined a young data model for microwave topology. This microwave topology draft is argument on T topology model, which is also argument the network topology model. The use case of the microwave topology, we are thinking about the following two kinds. The first one is for resource management. For example, you could expose the radio link frequency to the topology, and then enables you if you want to do rate planning on the frequency, for example, to decrease the interference level of each radio link. So that could be one possible use case. Another important use case is for path computation, as it's been introduced for several times that this radio link will have the feature to change its bandwidth. So it is important to understand what's the current bandwidth of the radio link. And so we included this information into the microwave topology model. And also in our case that we will use the availability to describe the link characteristics. So we will also report through the topology model. And then this is the topology Yang tree. It's quite simple in the first version. We introduced a new network type, which is microwave topology. And then under that, we argument the T-link attributes, which includes link frequency, channel separation, or you could call it channel bandwidth. We use channel separation in our case. And then also have a nominal bandwidth and current bandwidth. Sure. And then the link availability. So I would like to explain how this model is related with the microwave interface model, the one you guys have just introduced. I list these two models under the architecture by using architecture of from the ACTN. So in our understanding that the topology model is expected to used as a network service Yang model. So it should be used between the MDSC and the PNC. While the interface Yang module is defined for the physical link configuration. So it's a kind of a device configuration module, which is supposed to be used between the PNC and the network elements. So at the level of the PNC, we're expecting that PNC should convert the information from the topology model into the interface model. For example, the link frequency from the topology model should map to the TX frequency into the carrier termination of the interface model. So there's some mapping between the two. And it is also explained that in RFC 8199, we have different layers of the models, and it is possible to reuse the low layer Yang models by the higher layer modules. but we are still need to explore more how exactly this mapping could be achieved. And then in the draft appendix, we add 2 JSON examples because we thought that the JSON code will be quite helpful to understand how to use these young modules. The first example is about the single microwave link, which is the simple case. And here we demonstrated that the client signal will be Ethernet. So it's kind of an Ethernet over microwave link. And we use the multi-layer topology, the concept from the TE topology. So at first, in the Ethernet topology model, you will see there's a Ethernet TE links. And then these TE links will have a underlay containers, which is supported by the termination and the terminals in the microwave topology. And then in the lower layer, the TE topology of microwave, you will see the microwave terminals and the microwave links. And under the microwave links, you could say what's the data node definition we just introduced in the former slides. The second case will be a little bit complex than the first one, which is the client signal will still be the Ethernet service. And then the second, we will use 2 microwave link. We call 2+0 to transport the Ethernet services. So we have several discussions with some of the TE topology authors regarding how to model these 2 microwave bundle links. Here it is showed that we use the bundled case in the TE topology. So you could say that the Ethernet topology will be same. So I didn't repeat from the former slides. And this slide, you could say at the microwave topology, we could have the 2 component links. But there's different ideas whether these 2 component links should be shown at the TE topology view, because there's arguments to say whether these microwave links are TE links. But my personal question is that if we don't show that in the microwave topology, then where we can get this link attributes for this each individual component links. So this is a little bit unclear to me right now. And then the next one, last page is talking about the next steps. The first plan is that we will update the draft again. We received some offline comments to complete the JSON example in the appendix. And then it is planned to, in ECMWT, to have a microwave SDN plug test. And this microwave topology model will be verified in that plug test. So we are expecting more update according to the discussion. And finally, we would like to propose to use this draft to as a starting point to define the microwave topology young module. So we would like to ask for working group adoption. And finally, this week we will all have a side discussion, and if you are interested, you are welcome to join us. Okay, thank you.
Comments?
Hi, Amy. Luis Contreras from Telefónica. Just to be sure that I understood properly the proposal. So this topology model would be, would allow to expose the information of the topology for sure, but also could be used for configuring the device. How? Because you mentioned that in the topology, maybe you could specify the frequency and this frequency be configured in the device later on. Would be the case not only to expose information, but also to allow configuration?
I think so. As you can see from this, the figure on the left, and from the top, we will use the topology to config, and then the controller, the PNC, will convert that into the interface module, so which allows you to configure on the physical device.
Okay, so if we would have, I mean, we could have different southbound interfaces, for
Yeah,
different
yeah.
models, even proprietaries
Yes,
and so
yes.
on. We just, okay,
Yes.
okay,
So-
thank you.
So, Amy, one comment. So could you move to the next page? Next one. So if you are going to, if you need to show the detailed information of the component links, why not just treat the, component link, one single component link as one T-link, one bundled link?
So according to the definition from the T topology, and actually you will see that the LTP1 and LTP2 are actually the physical link, and this one is the component links. While then there's a bundle links, which is LTP3, so it's kind of a virtual link. That one is supporting the microwave tunnel. So we discussed with Shifeng and also Sergio, and we have the discussion whether this, in such a case, it is whether these two microwave links are T-links. So we have kind of a different idea about this. But I think it's kind of a generic problem, because I see in the Ethernet level, there was also Ethernet lag. So, but I talked to several people, and it is same. It seems it's not been discussed in the NBI design team. So this is the first proposal. We propose how to model the radio link in. But if there's better ideas, then we could update according to that.
Thanks.
Okay, good morning. Good morning. This presentation is an update to the GMP's routing and signaling framework for Flexi. It's okay, better? Okay. Yeah, thank you. Oh, not direct. It's technical. Yeah. Yeah, here's an update to this draft. What happened since last item meeting? So we update a new version, version 5, and add a new section to this version. It's mainly about open issues. And as a note said, this section is not intended to be removed when it is published, and also it's just as a trigger to trigger more discussion about whether the issue about RSPT session for layer, which one is better, or which one is better, and which one should be adopted by this work. And also in this update, we made some minor editorial changes. And also there are some work remain to be done in the future version. And first one is about to some final cleanup of the requirement. Also, maybe some parts of the text maybe need to separate it to different documents. So here's just a reminder what how GMP's control plane can be used in the case of Flexi. So here we can say that we think that GMP's control plane can be used to set up Flexi group and Flexi client by using the communication channel of Flexi. And also, we can use the routing protocol to advertise a Flexi group and a Flexi client into routing system, just like advertise Loma link, for example, Ethernet link or other type of links. And also, we can, once the Flexi group and Flexi client established, we can use some signaling to set up, for example, we can use MPS RSP signaling to set up RSP over those Flexi infrastructures. So here's about this side is a summary about the open issue for now. It's mainly about the Flexi control plane. There's some question about the relationship between multi-layer and this RSPT sessions. Whether we, actually currently we list 4 options here. Maybe you can go. Yeah, this is the first one, option 1. For this one, there's only one session established. It can handle all layers control. For example, we can just use one RSPT session to set up Flexi group, Flexi client, or even to set up airspace over this Flexi lanes. And the second option is that it's just on the in opposite direction. Just like for each layer, we can use a dedicated RSPT session. For example, the Flexi group can use a dedicated session. Flexi client can use a dedicated session. And so this way you can, each session can just only retain its necessary information and exchange necessary information. Don't combine.
Can you speak a little bit louder, please?
Okay.
Thanks.
Maybe strong direction. Yeah, this is option 2. Option 3 is just like it's a mix of option 1, option 2. In this option, we can just use one RSPT station just only for the, for example, only for the Flexi related layers. For example, Flexi client, Flexi group, just use one RSPT session, and for upper layer control can use another dedicated RSPT session. So option 4 is about this is a similar like option 1, but here's a difference that for each layer you have it will have different dedicated control plane, and and also has dedicated RSPT session. Yeah, and regarding the next step, we hope there are more review from the working group, and also solicit more comments from the working group, and we also think that maybe it's the right time to ask working group adoption.
Which is the option that you are suggesting?
We don't have preference for now. We just want to get feedback from the working group.
Well, okay. Well, identifying the pros and cons could be helpful to make a decision. Actually, I would be in favor of number 3, to do everything that is Flexi together and everything that is non-Flexi in a different section. The one you call 12, yes, exactly. But I would need to understand better pros and cons.
Dieter Beller, Nokia. At the previous IETF meeting, when this draft was presented, we actually provided some comments also on the mailing list after the meeting. I think in the replies to that email, I understood that some of the concerns or comments that we made have been confirmed. And now looking at the latest revision of this draft, I don't see that these comments have been incorporated into the document. So what are the next steps regarding these comments?
Yeah, maybe we missed that comments. Maybe we can just, maybe we missed that comments. We can just, yeah, to review the comments from the mailing list and try to address it in the next version. But for this update, we just add a new section to discuss open issues.
Okay.
Okay, well,
I mean, there were some severe issues which we brought up related to the FlexE implementation agreement. So we believe that there's functionality described in the draft which is not covered by the implementation agreement for FlexE.
I don't remember the discussion honestly, but you said that you agreed on the resolution of those major comments. You agreed on the resolution of the on a solution of solving those comments.
No, it was confirmed that the concerns we raised are valid concerns, but they were not taken into account when the latest revision of the document was produced. So, as it was said, the latest update that's presented here is just providing a new section with open issues, right? So,
could you please revive the discussion, please?
Yes, I can.
Thanks.
Thank you.
So Mark, so this is fantastic individual. I have a quick comment. So why you need to introduce these 3 types of the multi-layer control options? Do you mean that the existing solutions or approach for the multi-layer cannot satisfy FlexE scenario, or do you need something new?
No, we just because there's some discussion among the authors, and yeah, there's maybe has some different thought on this. So we just want to give an open discussion on this and whether which one is more suitable for this kind of use cases.
Oh, you mean this kind of thing just for information? And for example, if you just pick one of the 3 types options, do you need some different protocol extensions?
No.
No?
I think no.
Okay.
Because this draft it is only about the framework and yeah, so that's not all about extensions to the protocol. So.
One clarification question for Daniel. Okay, you just said using the option 3 is the right one. Are you talking about this one? Okay. So I think you're talking about this one. Top 1, 2, or top 3? This one.
You call 12 the option 3, but
okay. This one.
the third.
Okay. Thank you.
Okay. Hi everyone, this is Chile. This topic is about the GMPS control of beyond 100 gig OTA network. It's one framework document. Okay. The second slide is just to tell what happened during last IETF meeting. And during last IETF meeting, face-to-face discussion happened among the authors and the contributor of the draft that's based on the 2 typical scenarios depicted in appendix of Z.709. And the discussion are mainly on the challenges to the control of beyond 100 gig network brought by the emergence of OTOCN and ODOCN, as well as some potential extensions needed to GMPS signaling and routing protocol. We just talk about this. So let's take a look at the scenario first. The first scenario, it's just the finger is copied from J.709 and rewrite, but it's not different. In this scenario, it deploys OTOCN and OTOCN diagram between 2 LAN ports connecting to layer 1 or layer 0 audio cross connects within one optical transport network. One OTOCN is actually carried by one OTSRG or OTSA, that is the optical path. So after discussion,
We also think the ODU-CN and ODU-CN link can be automatically established after or together with the setup of the optical path. This is the first scenario. And the second scenario is a little complicated. In this scenario, one end-to-end ODU-CN is actually supported by 3 different OTU-CN or OTU-CN-SM segments, which are in turn carried by the optical path. In this scenario, just after discussing, we think in this scenario, the OTU-CN links will be established automatically after together with the setup of the optical path, while we think there are still some doubts about how the ODU-CN link is established in this scenario. Especially what I'm talking about is at the transponder point, how to set up an end-to-end ODU-CN link across the transponder, connect the two OTN cross connects. So this is the second scenario. Just based on these 2 scenarios, and after the discussion, we can conclude that it may some uncertainty about the setup of ODU-CN link. We think that it still exists, and this uncertainty may have a relationship with the progress in RTOT. So it's still not clear, we think. And the author and some contributors, we just decided that the scope of this draft currently maybe we should mainly focus on how to set up ODU-K or ODU flex ISP over ODU-CN links. We also give some evaluation to the current extension of GMPS signaling and GMPS routing defined in IFC 7138 and IFC 7139. After discussing, we think that the signaling and the routing mechanism defined in these 2 IFC, we think that they can be reused to help configure the ODU-K or ODU flex ISP with no changes once the ODU-CN link is already there, it's configured. So that's what we have discussed during the last IETF meeting. So the next page, I just gave an example. That is how to use a label format defined in IFC 7139 to describe how to multiplex ODU4 onto ODU-C10. I think in this case, one ODU-C10 has 205 gig slots and 20 of them are allocated to ODU4. And about next steps, I think we should invite more review and comment. And then maybe I think I can propose a request for the working group adoption. The reason that I want to request for working group adoption is because 2 reasons. The first one is I think I talked to a contributor also, but not, I get feedback from them, but not all of them. And I think we have achieved an agreement on this, on the scope. Another reason is I talk about the stuff in this draft with RTOT experts in question 12 and question 14, both through mail and face-to-face. And the feedback I got from them, I think it's positive. Some of them just tell me they think it's correct. So based on this feedback from them, I think maybe it's time to request for working group adoption. I think it would be a good start point. That's all I want. Okay, thank you. Comment.
Iftikhar, no, Infinera, just quick, I guess, just trying to summarize. I guess, are you saying that, because I missed the last meeting, so I guess the conclusion is that based on the current scope of the document, there's no need for routing and signaling extension. Is that correct?
Yes.
And okay, so, and I think you just mentioned you had a conversation with the ITU experts and they verified your, did you send that actually could you send that, is it okay for you to send that email exchanges to the list or?
I sent the email.
If it's
yesterday
okay,
evening
I mean, if it's appropriate.
Because I talked about this with them last week.
Okay.
Okay. With ITU guys.
Yeah. Okay.
Once the document is adopted, we can send a liaison.
So, Chile, I would like to double check. So, do you mean that there's nothing to be extended further, beyond 100?
Just based on the current scope, we just want to, let me show you. The current scope, the author decided, the second bullet, the scope of this draft is mainly focused on how to set up audio key and audio flex ISP over audio C links. That's based on this, we think there is no need to extend the current protocol based on this scope.
So you mean that we can just use the existing RFCs like RFC 7139, right?
Yeah.
And to set up the connections for the beyond 100G OTN.
Yeah.
Oh, and then my question is, what's the value of this document if there's nothing needed, nothing new needed?
I think it's because of the emergence of the beyond the 100 gigs, such as OTUC, we need to tell something about it because that is still not documented in current IETF draft, any draft. No, so I think maybe we need such a draft to document this.
Yeah, I'm a little confused about looking at the agenda and the draft itself, and now this discussion is even more confusing. So in the agenda, it lists essentially two titles, and I couldn't figure that out because it looks like there was a framework and a solution. And then in the draft itself, the major title is the first of those two titles, and then the title at the top of each page is a BGP, or not, sorry, the extensions, the whatever it is, 100 extensions. So it then looks page by page like it's a solution document, and I'm trying to read through it, and I'm not really seeing anything. And it seems to me that now we're saying that there's no solution in it either. So what is really the point of the document?
Actually, I want to give some explanation. I think the solution is needed, but we don't need to to do some activation job to current draft. I just want to give some evaluation, give some analysis that the current mechanism defined in this signaling draft can be reused. It's because of the emergence of some new stuff. That's what I want to say.
And that wouldn't be done here? Is that what we're saying?
Yeah, I think.
So this is not a publication forum. I mean,
I would say that a sort of applicability of existing GMPLS extensions defined for G709 version 3 to this work could be something useful. Obviously, we need to change the name from framework and extensions to applicability. But
yeah, with that change, it would make a lot more sense. Thank you.
Okay, thank you.
Thanks.
Hi, I am Yang. I'd like to present Yang models for flux grid optical networks. This is basically a tunnel model. In the last IETF meeting, the working group has accepted topology model And actually, at the time, I presented both models, but this model has not been polled on the working group. So I basically represent the same material without much change, but I like to give you some background. So this is based on RFC 7698, the framework and requirement for the flex grid DWDM networks. This basically augments T-tunnel model. So major changes from the previous version is basically we separated out from topology model from tunnel model. It used to be one model, and a link channel is now reusing LSP from T-tunnel model as opposed to private extension, and NMDA compliant. So this is basically a young model that we augment from T-tunnel model, as you see here. And I believe all the layer 1, layer 0 young models have been adopted except for this one. And this is probably the last one to be adopted and move on after base T-tunnel model has been stabilized. So I think it may be time to adopt this work.
It was mostly a matter of time, because we have pulled I don't remember 4 or 5 documents in a row. Yeah. So it's not just that this one had something wrong. It was just a backlog full of documents to be adopted. But let's try to see if what the working group thinks. So how many people have read this document? Quite a lot. How many people think this is a good starting point for a working group document? Less than the people that read it. So I would like to ask people who have concerns to come to the mic and say why they didn't raise their hand. Let's try again. Who is against adopting this document as a working group document? So I made a mistake counting the hands. Okay, we will take this to the list in any case. No, Tom, you have a concern.
Tom Petch. Like in my comments on the previous ID, my comments are more sort of administrative rather than technical. That is, I see a lot of Yang models containing very good technical stuff, having the right sort of objects, the right sort of characteristics and so on. But the rest of the information around it is lacking. And my comments I've made, which Jonas has very happily picked up, were mostly along that line. And so what I'm looking at is a Yang model and looking at the guidelines that have recently been republished and seeing how well does it conform with the guidelines. And so the reason I didn't raise my hand to your second question is the lack of conformance to the guidelines. Maybe the author's very happy to take all that on board and fix it, but I haven't yet got to the stage of actually posting a comment on the list and seeing what response I get to comments of that nature about, the copyright being wrong, the lack of references, there being references embedded in the wrong place. There's a whole raft of things in the guidelines for producing a Yang model, and it's the conformance to those that's my concern, rather than the technical content, which I suspect will be of the interest to more of the audience here.
Igor Briskin, Huawei. So I understand that you augment base T tunnel, right, for the FlexiGrid model. So the question is, would it be better to have like a richer hierarchy of the augmentations? for example, to augment say layer 0, T-tunnel, right? And then out of that, FlexiGrid. In this direction, we could, it could be like a more ways to explore and to make leverage of previously provided functionality, right?
So Igor, when you say layer 0, do you mean WSUN?
Yeah, I mean just simple lambdas, right? The single channel lambdas. And then based on that, obviously there are a lot of things that could be covered there, which certainly could be reused for FlexiGrid, like optical impairments, for instance, right?
Yeah, actually, this was discussed previously, and then for topology model, not to mention this tunnel model. So I think working group chairs suggested just stay with WSUN and FlexiGrid separate for topology model. So we just follow the same pattern. When you augment, actually, it doesn't make much difference at the end. Yeah. Okay. Yeah. So it's more logistic issue, and I think working group has already made the decision to go this way. So technically, it doesn't make much difference, but it's not beyond my capability or beyond my so I think it's a question to the working group chairs, because you have made that decision for topology model. So we just follow tunnel model same way.
No, I just say if you separate tunnel model from topology model, that makes perfect sense, right? But if you, for example, use two augmentations, separate augmentations from the base T tunnel model, one for lambdas and another for FlexiGrid, then obviously would have to repeat many semantics, right? In both, like for example, to do with optical impairments.
So your concern is when we do optical impairment augmentation, where we start, whether this model or WSUN model, right?
Yeah, I suggest to start at where it starts, right? Yeah. In with single channel lambdas.
Yeah, I think this is something to.
Honestly, I don't remember this discussion.
Oh, you don't remember? You are the one who pulled and adopted topology models. So, okay, I think that point is valid, I think, Igor. But we'll discuss with working group chairs and also authors of this document and WSUN. And in terms of Tom's comment, conformance, I'm not sure what was the real comment. I'm sorry. What do you mean by conformance? Document is lacking conformance. You said technically it's okay, but document needs to be more conformance. I don't understand what conformance means, so that I can pass down to the authors.
We can have a further explanation. Maybe you should sit closer to the mic.
I started sitting here, and there's so much noise in the room next door, I couldn't hear what anybody's saying. So I moved to sit in front of a loudspeaker.
It was just kidding.
Tom Patch, again. Yes, what I'm saying is that you say it's NMDA compliant, and that's excellent news. My question is, how much does it comply with the guidelines that have just been republished for authors of Yang modules, laying down what should be there in place of copyright, RFC name, references, how references should be handled? There's a whole raft of things, and every Yang model I look at, apart from those produced by the NetConf, NetMod working groups, every Yang model is defective with respect to those guidelines. And so the starting point for me is, how receptive is the author to changing it to be like those guidelines? And I'm saying Jonas earlier is very receptive. So that's good news. I have a lot of faith in the rest of that model.
Okay.
Yeah.
I understood. Okay. I clearly.
This applies to all drafts, I guess.
Yeah, absolutely. Yeah. So this is just, yeah, I think I understood your point. Okay.
Thanks.
Okay. Good morning, everyone. This is Hao Man from Huawei.
I'm going to introduce the update from 3 different documents, including the client signal Young model, client topology Young model, and the client tunnel Young model. So we have these 3 models application applied in different scenarios, and this is the second 02 version we are having. So we actually did receive some offline comments after we upload the document this time. And before my introduction to the update details, I would like to firstly answer 2 typical questions. The first question would be, what is the relationship between this work and the layer 2 or 3 service model? As we are focusing currently the Ethernet model, I think the layer X SM is mainly referring to the layer 2 SM. So we try to explain this by using the figure. Oops. Can I use this? Okay, use the figure in RFC 8309. And what we can see is the layer 2 SM is a kind of customer service model, which is referring to the interface A, notation A, between the customer and the service orchestrator. So, and the models proposed in this draft, the client model, which is mainly the Ethernet model, is a network configuration model which can be directly used between the controllers for Ethernet configuration. So that's a different applicability for different set of models.
Question, Omian. Why a network configuration model and not a service delivery model?
Sorry?
Why a network configuration model and not a service delivery model? Because what you're doing is a service.
Well, actually, well, there are something certain, something uncertain. The certainty is the model in this draft can be considered as a network configuration model. This is the first issue. And second, on considering the service delivery model, we should, I don't think we still we have a consensus on whether it belongs to this and whether the L2SM is also the service delivery model. We need to.
I agree with you that this is not a customer service model.
Right.
But please consider analyzing it, whether it applies to the service delivery model.
I think it will definitely make sense if we can really figure out how this model works together with the layer 2 service model, of course. And the second question, okay, is actually a follow-up of the previous question on how this model is applied, because of we have 3 drafts, including 4 different YARN files, then how it would be applied in the real network configuration. So here we propose actually 2 separate different application scenarios. The first one is Ethernet only. We consider Ethernet as a transport network, and we do not consider any client in this scenario. That means we only have a flat layer of network that is composed by Ethernet nodes. So consider it as a single layer technology, then it would only be necessary to set up the Ethernet tunnels using the Ethernet tunnel models, and this should be based on the Ethernet topologies that are collected from the controller by the Ethernet topology model. So this is respectively draft number 3 and draft number 2. And the second scenario would be a kind of application of Ethernet as a client of the transport. So in this kind of scenario, the Ethernet need to work closely with the OTN node, and there may be a single box that integrates both Ethernet and the OTN nodes. So what we need to configure is Ethernet access link in the 2 sides of the figure, and we need to configure this service by using the client model in the draft number 1. And after this is done, we also need to report the Ethernet access link to the controller. So we also need to involve the topology model. So basically, this would be updated for both the Ethernet nodes and the Ethernet access link. So after the clarification, I would like to introduce the changes from the previous version. And firstly, we make it an MDA compliance for all the 3 drafts. And for the first draft, we had adjusted a few Ethernet modeling parameters. We added some groupings for Ethernet service performance monitoring threshold and the statistics. We also add the leaves for a time log. When did you create, when do you update any certain service? And we also add more types, including P2P service and the RMP service, and so on. We also provide some more text to describe the model.
Sorry to interrupt.
Please.
Just we had this discussion on tiers about the service mapping thing, right? So service mapping actually occurs in the same layer. So you have a service, for example, Ethernet service or IP service like layer 3 VPN service, right? And then this is what client sees that. And then you have basically the network operator, the provider, which maps the service in this layer into infrastructure in this very layer. Like, for example, in case of layer 3 VPN, you map layer 3 VPN service onto IPT tunnels, right? And you also map information that is seen by the client, like availability, protection, stuff like that. You map into the set of attributes for the tunnels that could be gathered from information about the service. This is one thing. And then there is totally different thing of, for example, a client service being in one layer and infrastructure in a different layer. Like, for example, say Ethernet service and OTN tunnels, right? Yeah. This actually what G805 calls adaptation. It's interlayer relationship. And this could be covered by the topology model, right? Because we have all the semantics basically saying that a particular tunnel termination point can adopt certain client links. So this need to be very clearly separated. Okay, so sometimes we hear this confusion that, oh, I have client service that I just can map on OTN, and why not simply directly on lambdas? Something like that. Okay, well, so I'd like to see that this clear separation, and we also were discussing some kind of generalized way to take care of T policies. Basically, when you want to map services onto the tunnels of the same layer.
Why are you saying that the T mapping in T's it belongs to the same layer? Because there we are mapping layer 3 or layer 2 services against the T tunnels. So it could be at any layer.
Well, for one reason is that, for example, there could be switching in this very layer, right? So, like for example, Ethernet services could be mapped on the tunnel that could be switched, but not based on like VLAN IDs, or it could be switched by, say, S-tags, right? This is one thing. But the other thing is that the adaptation is a totally different animal, right?
Yes, that's true.
Okay, so this may be a kind of challenges that to generalize the problem rather than separating the different scenarios. But we can work offline to solve this problem, to reach a balance between the two. Mike. Okay. Okay, we are here. Yeah, and actually, originally this draft is named as the OTN client signal YANG. So Ethernet is definitely one of the client signal types of OTN, but according to the OTN control plane draft maybe 7062. There are also other GP that has different client signal types, including those kind of SDH or something like that. So we also try to add another client signal models, and the basic shape would be shown in this figure. And after we compare this model we generated with the Ethernet model in this draft, we concluded that the client signal model is currently different with the Ethernet models, and it is really difficult to extract a common base as fundamental or generic models to augment from both. So we separate the two sets of the models currently in one draft, and maybe in the later version we are going to split it into different drafts. And okay, this slide shows the changes for our update on the client topology YANG. Again, we make it an NMDA compliance. We adjust some parameters related in Ethernet topology. The first one would be we removed the node MAC address, as usually this is not interacted between different controllers. And we also add some parameters to support the configuration of the symmetric or asymmetric bandwidth profiles on Ethernet links. We also add the support to reporting the VLAN classification and operations supported by access links. And we also change the types of client-facing parameters from empty to Boolean, as it will be clearer to understand how to use it. And we also update some text. So for tunnel model, there is no much update according to the model itself. We basically make it an NMDA compliance and update the text. And finally, this is the current open issues, and the first one is we want to broaden the scope of the T-tunnel server from OTN to transport, because this is according to the previous comments from chairs to make it generalized. So currently we hope we can at least make the tunnel server generalized, and so not only focus on OTN, but we also find it is difficult to make the client signal generalized, because the Ethernet is too much different with other kind of client signals. And we also received some comments offline from some operators saying that they only, or let me say, at least they are mainly focused on Ethernet models. So we would like to extract the Ethernet part of this works and move separately with the other kind of client signals. So we would like to ask for working group adoption, and we also notice there are some coordination work left between this work and the other working group or even standard organizations, including IEEE, MEF, I2RS, and NET models. So that's a plan for the work.
Dieter Bell on Nokia. I have a question for clarification.
Is it louder?
I have a question for clarification. You are saying that there are quite some differences with respect to the Ethernet model for client signals with respect to the other client signal types. Is that correct?
Yes, this is.
And therefore, you are proposing to have that Ethernet client signal stuff in a separate document, correct?
Yeah.
Can you explain a little bit what these differences are and what makes it so difficult to handle Ethernet client services in the same way as the other client services?
Well, if you look at the trees from the two set of models, actually Ethernet current models is very technology specific, and we include a lot of parameters that need to be configured on the Ethernet, for example, node and port and those kind of stuffs. But this would not be applicable to any other client service of OTN. And for those kind of common sense, for example, what is the client node, client link, that may be applicable to be found in TE generic models. So because this work is also augmenting the TE models, so we think those kind of the common area is already covered by TE generic models, and this we just make the Ethernet model and other client models augmenting to the TE directly.
Hi, it's Glenn Parsons. So I guess I don't understand. I'll start with maybe a clarification of this is OTN Yang, OTN being ITUT G709 Yang, I presume. And I'd like to understand why we're working, or you're proposing network management data models here in Ccamp as opposed to an ITUT study group 15, question 14, which is working on network management information models and data models and such. So maybe you could help me understand that first, and then I can make detailed comments.
Happy to do it, but prefer offline.
Okay.
Are you saying it is an OTN draft? No, actually,
So
this is a kind
I
of-
don't know. It says OTN in the title here, and
Yeah, the
it's an
title
OTN
will-
service, and you're having an Ethernet as a client.
Right.
And so now, if you want me to talk about details, why on earth are you creating a new Ethernet Yang model? There's already one in IEEE 802. There's several. There's one in MEF. ITU is working on one. We have liaisons between IEEE and ITU to work on one. There's activities in IETF on Ethernet Yang models that we're working with. I don't understand why we need an OTN Ethernet Yang model, but perhaps I just don't understand.
Yeah, I
Maybe
think-
you could help me understand.
Yeah, I think we need to separate your questions one by one. So consider, okay, this work is specify the model how to configure the Ethernet service given there is a transport network that's carrying the Ethernet service. And the basic idea is to configure the Ethernet access link after to make sure that the Ethernet service Ethernet connection is correctly configured over OTN. And according to your comments on other progress on other standard organizations, my understanding was MEF defines some kind of Ethernet service types. And that would be a kind of service here. Can you specify what is MEF is doing? What is
Yes,
IEEE is doing?
MEF is defining service for Ethernet. There's sort of
Right.
3 levels. It's a very complex
Yep.
life cycle service orchestration model with multiple types of service, different abstractions from business relationship, service relationship, network element relationship. That's the MEF. And then IEEE is working on the detailed pieces. There's liaisons with ITU in question 14 on some of the details. And then there's the L2SM work here, which is in a different group. So I'm just trying to piece all this together because,
Yeah.
I mean, every group I go to, there's yet another Ethernet Yang model.
I tend to agree that it would be helpful if we put everything together and see whether there is anything inconsistent. And,
Yeah, I mean, from my perspective, there should be like a base Ethernet Yang model, and then you augment it because there's like so many VLAN objects and MAC address objects and so on. Anyway, so I'm just trying to understand, but we can discuss offline if you'd rather do that.
And Amy, actually, I would also add into Glenn's comments. At least I'm aware of that OMF is also have an Ethernet PHY management model. So I agree that there are several still that are defined, looks like the same thing. So we need to put them together and say what's the difference. And to me, I think I also look into the MEF Ethernet service model. I think that one is clear because it's kind of a very high level use at the customer service delivery model, so which is different from the current one, but we may need to explain more how it's related with the REST, IEEE, and IITUT models.
Thank you, Italo Buzzi from Huawei. I would like to help as well. I think if you look at this picture, what Amian is clearly shown that we have the layer 2 SM, which is applicable between the customer and the service orchestrator. And what we are doing is now is working on the interface on top of the controller. On that interface, what we are using is the T topology and T tunnels models that are defined by T's. And what we need in that area is technology-specific augmentation for OTN and for creating Ethernet services over OTN on that level of abstraction where we have a T topology, we have the Ethernet LTPs, we have to clarify, and the T topology gives us the interlayer lock to let us know, for example, from which Ethernet access link, which OTN tunnel TP we can use to create. If you want to create an Ethernet service, we need, from one Ethernet access port to another Ethernet access port, we need to know between which OTN TTP we need to set up the tunnel, and that's the interlayer lock information that we get from T topology. So we need to expose at that interface the Ethernet topology access link, its interlayer lock, the TTP of the OTN, and all these attributes. And this work is not going to be done anywhere. And my understanding is the IEEE model is more 802.1q bridge management, so it's more a part of the device configuration model. So they are applicable on different part of the overall control architecture. Thank you.
So what is missing in other models is the mapping to a tunnel or a topology.
Right. Yeah.
So let's try to focus just on what is missing. Try to avoid the duplications.
Igor Briskin, I also would like to answer, the previous gentleman, I didn't get his name, but the thing is that if something is called Ethernet YAN model, a huge number of different things could be named by that, okay, and huge different of aspects could be also considered. Like, for example, say, MEF can define, I want to have, say, EPL, which is time constrained. It should not go beyond, say, 10 millisecond latency, right? But how you can actually achieve this, that's totally different problem, right? So for example, it is quite possible to separate responsibility and have, say, MEF define network-wide service model, basically how the client perceive this service. And then there could be infrastructure model, which is which has a lot to do with traffic engineering and provide, for example, the necessary disjointness or delay or bandwidth. And then there should be a third type of model, which basically it's a device-specific model, which can tell each device on the edges of the service how you map the services onto the infrastructure, right? That's a third type, and all of these things are called Ethernet, right? And some of them are developed in IETF, some of them are developed in different organizations, and even in IETF, some of them have to do with like service and like connectivity restraint, and say VLAN IDs to like CTAGs mapping and stuff like that. But some, like in Ccamp and TIAS, this has a lot to do with the traffic engineering particular layer, and also what we contribute to the community as how this infrastructure could be mapped on the services which are seen network-wide.
You can go to the next presentation.
Oh, yes. Yes. Okay, this is a second presentation from me, but on a totally different topic. This is not young. This is talking about the interworking of the GPRS control and the centralized controller system. So this has been the second presentation. Last time we did this in Singapore and briefly introduced the motivation of this work. So things are now becoming different after the appearance of the controller system. Originally, the control plane is fully distributed with GMPRS protocols defined in IETF Ccamp working group. The protocol includes the RSVP, OSPF, LMP for different functionalities. But nowadays, we are introducing the controller system in the whole area for a kind of centralized control, because we believe there are some advantages for the centralized kind of like path computation, routing, and stuff, and so on to get a better performance and understanding. So the corresponding output from the centralized controllers may have the ACTM framework and the controller hierarchies. We also have RESTconf, NetConf, and together with Young models, and also the PCE protocols, especially for path computations. So the changes from previous version, we have 2 new co-authors, and we have also updating the scenarios, which we think this is the most important for this kind of informational work. That this kind of scenarios are requesting the interwork between the centralized controller system with the previous distributed control plane. So the scenarios include topology collection and synchronization, multi-domain or layer service provisioning, and controller reliabilities. I will expand in the future slides. And we also update the reference. So here is the first scenario. We want to analyze the kind of interwork in more detailed, because this is the most fundamental scenario in the network control. So given the group of devices composing some network, and it is now controlled by a single controller, and there may be a PCE embedded for path computation, and some other of the control functions need to be achieved by the interface between the controllers and the network elements. But given this kind of network architecture, we are trying to categorize all the interface in the networks into 3 different levels. The first level, number 1, is between the neighbors. We call this, temporarily call this the neighbor level interface. And the main function and requirement for this kind of interface is to discover the neighbor and support some of the exchange of information between neighbors to understand each other. And the second would be still between the network elements, but it's a kind of domain level, or we call this network element level. So even for those kind of 2 network elements is not directly connecting with each other, the informations can be flooded and received by each network element in the domain. So typical protocol would be OSPF or ISS on this level. And the third type of the interface is the interface that connects the controller with the network elements. So this is usually requests an interaction between the controller and the network elements. And the typical protocols include the PCAP and the NetConf with Young models. So when we really deploy a network, the topology is initialized and reported to among the network elements and between the network element and controller. So while LMP for interface type 1, OSPF or ISIS for interface type 2, and PCAP or NetConf for interface type 3. And when there is an update, for example, we add 1 node to the existing network, then we need to synchronize the information to all the other network elements together with the PCE, together with the controller or PCE level. So the changes for this procedure on interface number 1, type number 1, is we need a new node to create RSP, create LMP, and to every neighborhood, And we also need to flood this information to other related network elements. Finally, we also need to report or connect a new PCIe session from the new node to PCIe, or we need to notify the controller that this there is one additional node and the corresponding database need to be updated. So based on the topology collected from the controller system, it would be then to compute the path and deliver the service. And we have decomposed the service provisioning to a few different steps, including the first one would be the path computation, and then it would be the kind of path establishment based on the path computed in the previous step. And finalized, there will be a kind of database update, especially for the one on the PCE or controller in a stateful flavor, to make sure that the status of the network is synchronized in the controller. So the considering the perspective of node, actually the path computation and signaling can be either centralized or distributed, or a combination of the two. So in this table, we try to show how the different protocols is applied for the different tasks. So for a path computation, the distributed control plane would need to use OSPF protocol to compute the path. Well, if there is a centralized compute, we use PCE. No matter whether it is a distributed signaling or it is a centralized signaling, the PCE is used to compute the path. But things are going to be different once we need to separate the path. And usually for distributed, we can use RSVP. And in centralized path compute plus distributed signaling, we can also use RSVP. But this is the story for PCE initiated. And finally, if we want to centralize the signaling, we can also use PCP or netconf to configure the corresponding devices. And after the RSP is set up, there is a kind of resource update. Usually this can be done by OSPF or PCIe-RS. Question, please?
A question for clarification regarding the resource update. I think that can also be done using the netconf protocol, using netconf notifications, right?
Right. Yeah. Actually, we should list it also here and mention it in the draft. And the third scenario we add is...
Can you please end in 1 minute?
Oh, okay, sure. Okay, this is a controller reliability, and this is something new topic, and we focus on solving the problem once the controller is shut down. How will the full system act to solve this problem? Nowadays, we have two branches of approaches. The first one is controller federation by backup controller. And the second one is also you can rely on the distributed control plane, because we have the same functionality set, but maybe the performance is not as good as the centralized control. So to summarize this work, we have actually received good support last time and also received some offline comments to update into this version. And we expect the working group to reach a consensus on the centralized and the distributed protocols is now complementary with each other rather than mutually exclusive. So we are also open to all the variation on the details for these scenarios, and we would like to ask for working group adoption for this work.
Thanks. Next, please. No matter how much time we ask for, we are always late. Giuseppe, you're next.
One short question, Dieter Nokias. What are we going to do with this draft now? What is the conclusion from the chairs? The previous one?
Conclusion about?
He was asking for working group adoption.
Deferred.
Okay, this is a 0.1 version update of the layer 1 connectivity service model. You may recall the first presentation at last IETF in Singapore. So just a quick recap about what is the purpose of this draft. We, starting from the RFC 4847, we want to provide, that provides a framework about layer 1 VPN services, and in particular, this RFC describes in detail all the use cases and all the dynamic provisioning that was take for also the scope of our draft. So our draft provides a young data model for layer 1 VPN connectivity service model, and also it is based both on the work on that is made in this RFC 4847, but also is made in agreement with MIF work on layer 1 connectivity services. Now we can describe what are the most common deployment scenarios that are in scope for layer 1 VPN services. So the first, that is the basic use case, is for the layer 1 VPN for external customer. So we have that we want to model the interface between the customer service orchestrator and the network SDN controller. So this is not so common because should be difficult to have an external customer that asks for a simple layer 1 connectivity. But okay, we can consider this in scope because RFC 4847 consider this case, so it's better to consider also this deployment scenario. The second one is about the multi-service backbone for internal customer, that in our opinion could be the most common use case because it includes the interface between the SDN controller for different services, so layer 2, layer 3, and so on, and the network SDN controller for layer 1 VPN. So we are talking about a multi-service backbone that is shared for different departments that can control different services. This can be common in a large enterprise when an organizational design can ask for a typical hierarchy controller like this explained in this slide. Okay, this is just a slide to describe the difference between layer 2 SM, layer 3 SM, that are the other service model that IETF is working on, with the layer 1C connectivity service model. So first of all, layer 2 SM and the layer 3 SM are service models, so are focused on customer service interface. Layer 1 CSM can be the southbound interface of the service SDN controller towards the network SDN controller. So, and this is the typical architecture that I mentioned before for the multi-service backbone for internal customer, for example. Okay, this is the model. It is very simple. So we have addressed in this slide, we have addressed also one of the comments we received in Singapore. In particular, we put the UNI data client protocol and the value that this variable can assume was one of the comments that we received at the last meeting. So, of course, gigabit Ethernet, 10 gigabit Ethernet, fiber channel, and so on. Okay, in summary, some operators are authors of this work, so the operator expressed the needs and for the IETF layer 1 CSM. There are also some liaison with MIF, so we are working together to move forward also this work. Of course, this is in scope, in our opinion, of Ccamp working group, because this is the home of layer 0 and layer 1 technology. And so we are asking for working group adoption if you consider that document is stable. And
I'm one of the co-authors, so your turn.
Yeah, actually, I think even in the last Singapore meeting, we got consensus that this draft is really useful and helpful for the industry. So I think we would get the opinion from the floor again. So how many people read this draft? reasonable numbers. So how many people think that this draft is good foundation for this work? Okay, less than the people read this draft. So maybe we can take to the list for more discussion. Yeah, okay, thank you.
Okay, thank you.
You have 30 minutes for 5 drafts. Decide how you prefer to split the
I
time.
was supposed to have 25.
But you have also Rudiger's slot.
Yeah. Okay. This is Gabriele Galimberti speaking. Okay, the first draft is again, sorry, I apologize for my voice. Is again on the extension of the signaling for SSON. In particular, we want to address the case to signal the carriers inside the media channel. Basically, what we have today is a pretty good draft, like 7698, that defines all the parameters that must be signaled through the network to define, to let's say, to identify and distribute media channel information. But we don't have the possibility, or we don't have yet the way to signal what is inside the media channel. Inside the media channel, there can be either a single carrier, or there can be multiple carriers. And multiple carriers are, of course, following the same path, so the same media channel, should be the same type, because is very likely, or they are carrying the same payload, so they have to they must be routed in the same way to comply with the SKU and all the stuff. And then the position of the media, the carriers needs to be identified to signal or to be provisioned to the client ports where the transceivers are. On top of that, let me go, okay. On top of that, we saw that also inside the ROADM, so the pure ROADM, not the transceiver, there might be the need to know where exactly the carriers are positioned inside the media channel. This is to make the optical channel monitoring operations easier and faster. So using this slide, I would like to go more in detail on what's going on here. So on the, you see the picture of the network. Sorry, I cannot use the pointer. And you see the EN node having multiple carriers connected to ROADM. There might be one port of transceiver EN connected to one port ROADM, or there must be, or there can be multiple ports of EN connected to a single ROADM port. It doesn't care. It's just a different way to model the interconnection. In any case, once the client asks for an LSP, so a media channel in this case, because we are in the SSON environment, may require, okay, give me give me a connection between the egress node to the ingress node to the egress node with this bandwidth, net bandwidth, for example, 400 gig, and I give you let's say the availability of possible 4 ports. Then this is signaled via UNI to the GMPLS, and then is the GMPLS deciding, number 1, the routing, number 2, the media channel width, and the media channel width is actually depending on the modulation format, on the FEC, and on other optical parameters. So what can happen is that the control plane may decide, for example, to implement the 400 gig LSP using, for example, all 4 ports, because the circuit, the LSP length is so high, so that has to use a modulation format like QPSK, which is pretty performant but low bandwidth, and then so make a media channel pretty wide, because it has to contain 4 carriers, instead of, in case of LSP very short, like, I don't know, 500 kilometers, for example, where a different kind of modulation format like 16QAM may be used, and so only 2 carriers and only 2 ports are needed. In this case, the media channel will be a little bit narrow, let's say almost 50% narrow that the one that was carrying 4 carriers. So to signal all this stuff between either the client and the network and inside the ROADM network, we added some TLV that are used to signal all this information between client and network and inside the network, inside the GMPLS. And those parameters are, let's say, mentioned here. So the first one is for the request, the number of carriers that the client can provide, so the number of ports basically that the client can provide or can make available to the network to make an LSP. The total bandwidth, this is the total bandwidth is the net bandwidth, is not actually the post-fact bandwidth. So total bandwidth is 100, 200, 400, 200, 450, 500, whatever. And then other 2 parameters that, let's say, tell the network, okay, what I'm asking you, number of carrier, for example, I say 4, total bandwidth 400. These are parameters that are mandatory, or these are parameters that can be, let's say, best effort. So if you cannot give me 400 gig on 4 carrier, so give me whatever you can. And this is the S and B flags. When the GMPLS starts signaling, start calculating the optical feasibility and the path, of course, has to take care of the modulation format, the FEC, and the baud rate, the bit per the frequency of the symbols, the symbol rate, let's say. On top of that, GMPLS must identify per carrier, the carrier identifier, that is basically can be a simple number, simple integer, 1, 2, 3, whatever. J, which is the granularity of the frequency for the carrier, and K, which is the distance of each carrier from the central frequency of the media channel. We saw that also the power, the subcarrier power, could be useful. In other words, what we have done is keeping whatever has been already defined in terms of media channel definition, which is M and M, and then here is actually shown in the picture. We identify the parameters that is K, K1 and K2 in this case, where K is, let's say, the distance again between the media channel central frequency and the real frequency of the carrier. So now we define the granularity of the media channel or the carrier frequency at 0.1 gigahertz. Probably 0.1 is not a good one, could be 0.05. Otherwise, we are not matching 6.25 and whatever. But again, this is what is done so far. Again, we have the association between each carrier and each ROADM and the client port. That is all we have done. Of course, has been done as experimental that is now actually up and running because we have application doing that. We wanted to propose this method as an example or as to share everybody what has been done, because we think we are addressing a real problem, in the sense that if you want to make a multi-carrier media channel signaling today, okay, there might be different solution, different proposal. I'm personally not aware of. This is one. So if you have positive comments, are welcome. If you have negative comments, are welcome as well, because we can let's say share different kind of experience, and maybe we find out even a better solution. Having said that, okay, at this point, as this document didn't change since the last IETF, probably is worth to become a working group document and then be open to any contribution.
And I guess the negative comments are coming.
Dieter Beller, Nokia. I don't know whether they are negative. Yeah, to some extent, probably. Are you aware of the latest developments at ITUT study group 15 regarding inverse multiplexing and OTS-IG, because they are moving in that direction as well? Second point is they're actually addressing services with a larger data rate, so it's beyond 100 gig. And looking at this, looking at the subcarriers, it looks like the granularity that's currently defined in FlexGrid is sufficiently low. So this is 12.5 gigahertz, and I think this granularity is probably suitable also for these kind of applications.
No, that's a good point, Dieter, in the sense that, yes, we are aware. I think this can be in some way extended also to OTUCN, and then also to OTUCN / granularity.
Well, the UCN is on the electrical side. That's addressing the client layer signals. On the photonic side, it's the OTS-IG signal that's currently being defined or has been defined in IQT. Okay.
Yeah, probably what we miss here is the link between the DWM part, because here actually the client is terminated inside the router. So we have a DWM interfacing the router, so we don't pass, we don't have a clear mapping between the Ethernet traffic and the OTN. But sure, I agree with you. If you have a transponder, I think we miss something. And
again, regarding the granularity, I think this draft is actually moving beyond what's standardized for the G709 data plane, right? Yeah.
Thanks. Good suggestion.
You can go on.
Okay. Next step is, of course, actually should be the first step, this one, because first you have to agree on the interfaces and then you can start signaling. But in any case, it is what it is. The extension of the LMP to support all the information related to the interfaces and how the interfaces are connected to the network, and what kind of characteristic those interfaces have. Basically, the characteristics did not change since the last draft, since the last IETF. Let me see. Okay, this one. So basically, what the client can tell to the network is the kind of modulation format, the FEC, the baud rate, number of carriers that are available, bit per symbol, so basically the spectral efficiency, subcarrier band, so the minimum distance that should be taken between the two subcarriers, guard band in case of a carrier is, let's say, at the side of the media channel, so basically the filtering guard band, and then TX and RX power, OSNR robustness, and max polarization power difference. So the difference between the carrier power. That is, again, to be honest, not implemented, this one, but is something that would be beneficial. It's not implemented because today we share this information between the client and the network using the controller, the centralized controller, basically. That is the reason. But if you have a full GMPLS network not having the controller, at this point, the LMP and sharing this parameter is mandatory. Again, comment, positive or negative, if you want. Okay. No, it's actually an extension of the LMP document we have together.
So Gab, thank you. So I have one comment. So besides the OMP, so do you think if it's also possible to use the routing protocol, for example, OSPF-TE, to advertise the link capability?
The capability of the transceiver, you mean?
Yeah. So for example, there's a link, there's just two ends of a link, and this end can advertise the capability of this end, and another end can also advertise, the capability of itself, and then the one other network can get the the link information, because they can coordinate this kind of capability between these two ends.
Yes.
Yeah.
You got a good point. It says that if the GMPLS implements source routing, so has to know, number one, the characteristic of the port at ingress, but has to know whether, and has to check whether the egress node has the same capabilities, or at least capabilities compliant with the ingress node, because otherwise the LSP is not feasible. That's it. Yes, the answer is yes.
Probably this is one of the most mature drafts.
Yeah, I'm pretty confident that it's mature because, as I said, we have an implementation up and running. We didn't see any big issues. Of course, as I said, can be improved, as Dieter said, and really appreciate the comment. But I think it's a good starting point. And if it becomes a working group document, then is open to any comment and any contribution as well.
How many
actually,
people? Let's see, how many people have read the draft? Some. How many people think it's a good starting point for a working group document? Is this the LMP one? LMP. Less than the people that have read it. Just two. We needed to further discuss this and try to find more support. Can you squeeze the next presentation into 5 minutes, please?
Yes.
Perfect. You need to switch.
We have two presentation. Okay. Okay, this is actually related to the LMP for DWDM interfaces, so exchange of parameters between client and network, and then the same information are, or different kind of information, or standard information, let me say, are modeled as a YANG. Let's start from the LMP consideration. I think this is really a document that is consolidated. In the past, we discussed quite a lot what to put inside the TLV, and then agreement has been reached, and so no modification was done since the last IETF. This one, again, is something that I believe is useful, and then can go through, in my opinion. The modification on the LMP document has been just editorial or just cosmetics. Let's go ahead. For the YAM models, okay, there are no changes, so the document is there. I think is covering quite all parameters that are needed to make the client and the network interface working, and that's it. then we can go to the.
Also, these drafts probably are at a point in which we should decide whether to progress them or probably stop working on this kind of activity. Well, now that the DWDM interface framework is an RFC, it was ready to be an RFC. Sorry, not yet. It's time to consider working on the extensions and not just keep the framework sort of uncompleted. So first, a question to you. What do you believe is more urgent between the Young model and the LMP extensions?
But to me, the LMP extension is more urgent because I'm aware of some interop test happening in an operator between different vendors, by the way.
Okay. So
and so we have been, let's say, pushed to implement this stuff. So in my opinion, the LMP is more urgent.
Let's start with it then. So LMP draft. How many people have read it? The same two people reading every document.
So we miss some people in this IETF, so that's why the support is.
This is just to have an idea of. We are not taking any decision with these pollings.
Okay.
Okay. Try to quickly address
The
this
last
last
one.
one. We have 2 more presentations, and then we're done.
Okay, I will be very, very short on the last one. No, this is still. Okay. This is actually reflecting what is already described in the Giovanni draft that is becoming working group document. So can be a parallel document describing what Giovanni has in his document, simply in a different model. So EM model, that's it. I don't want to enter in details. So if you want to have a look to the parameters that are described, again, I think can be changed and can follow, let's say, like a shadow, the new working group document that will become.
Okay.
That's it. Thanks a lot.
By the way, the draft that was read by 2 people has 8 authors.
I told you that we got some people not coming.
And one of the people that read it is not one of the authors. Likely decisions are taken on the list and not face to face.
Dieter Beller, Nokia. I mean, we had some email discussion on the Ccamp mailing list regarding impairment validation recently when during this poll of the encoding draft. I mean, my comments do also apply to this draft, of course.
Okay. Okay.
I'm Nicola Sambo. So this draft refers to a specific use case for a Young model for finite state machine presented in NetMod. So the use case is the following. What we want to do is to instruct optical transponder about recovery actions to do in case of physical layer degradations, or more in general, to instruct optical transponder about reconfiguration in case of physical layer changes. So here you can see the reference to the more generic Young model in NetMod. For flexible transponders, we mean transponders supporting the possibility of configuring several values of bitrate, modulation format, and code rate. So this set of transmission parameters, format and FEC, are configured based on some physical layer conditions, and they can be reconfigured in case the physical layer condition change. Normally, what's happened? So assume to have an active service connection. We have degradation at the physical layer, so something that can be seen as a bit error rate increase over some threshold. An alarm is generated toward the ONDM handler, or in general toward the management system. Does a new computation of transmission parameter is performed, and the SDN controller reconfigures the transponder so that the recovery can take place. So this operation can be time consuming, especially if several connections are interested by the failure. What we want to do with this model of finite state machine is to while the service is still active, is to instruct the optical transponder about the reconfiguration actions to do if some event happens, so that when this event happens, the transponders already know what to do, and they can promptly react. So this is the Young model. You can see the current state, which is defined by a specific configuration of transmission parameters, so bitrate, modulation format, and code rate. We have a list of states. To each state is associated a transition. So here for a transition, we consider a bit error rate change. With respect to the generic Young, more generic Young model, here we augment the model with the first two squared attributes, so the threshold parameter. In this case, we can set the threshold on the bit error rate or on the OSNR, and we have also a threshold operator. So operator, if the bit error rate is higher than or lower than, the transition is triggered. Then we have some actions. So in this case, the reconfiguration of the modulation format or the code rate, and after the execution of this reconfiguration, some new actions can be executed. For example, a new action can be the notification to the SDN controller that the reconfiguration has taken place. Then we go to a new state. So simply we can see this two-state machine. We are, for example, in a first state which refers to PM 16 QAM. if we have an event of bit error rate over the threshold, we can we perform a transition with an action of changing the modulation format to get a more robust transmission. But we can also come back to the state of 16 QAM if physical layer performance improve for some reason. So yeah, that's it. If you
Igor Briskin, Huawei. So let's distinguish soft failures from hard failures, right? So if it's a soft failure, there is no rush in do anything, right? So basically, something that goes out of like a normal behavior, and it is possible, for example, to update SDN controller, and he will actually explicitly reconfigure the device, right?
Yeah.
Yeah. So if it's actually hard failure, then sometimes there's no time for communication between the device and the controller, and you want the controller needs to know in advance. But in this case, it would be better to have like some hard configuration, such as, for example, parameters that are associated with the recovery options while the tunnel is established, versus to provide a script kind of flexible logic, which more flexible, however, it will be slow as well, right? So basically, where do you see the real value of being able to pre-program the actions in this flexible way, you know, like in your particular case?
So are you asking how much is flexible?
Yeah. No. I mean, this is all good when you want to have a flexible way to say that, you know, recover in this way, reconfigure in this way in case of those kind of failure, right?
Yeah. We can. An SDN controller can, well, the operator in general can think about to several situations and can program in the devices these several configurations.
But in reality, it would be some kind of script on the device running, right?
Yeah, it's on the device, but well, yeah, it's true. This use case specifically target a script to be installed in the device, because the problematic that we have seen with the operator, it was that we wanted to create more scalability at the controller and also a faster reaction. So for this reason, yeah, it's true, we install the script into the device, the agent. But yeah, this is the young model finally is so generic. It's a finite state machine. We can install it also at the SDN controller.
No, I'm not talking about SDN control. What I'm talking about is that you actually assume that, say, a device like RODOM have scripting environment like Python, for example.
Yeah.
Okay, and or some Tickler, whatever, and then you basically through Young model, and you provide a script that could be translated into the such script and invoked in case of failure. So what I'm saying is that it will contribute to the latency of the restoration, right? That because if you have like a hard programmed logic, it would be faster to do this anyway.
But if I may jump in. I would say that failures is just a minor subset of the things that you can do with the finite state machines. Yeah. There are many things. Let's not focus just on failures, because you can do a lot of things with the
then consider another situations like for example soft failures or whatever, anything prediction or whatever. So then where is the rush, right? So for example, why cannot I just notify the SDN controller about certain event, and then he will explicitly reconfigure? It will be easier for the controller to do this.
Well, it's not well, it can this reconfiguration could be also fast, not only could be done in a rush, and finally this approach is faster. Consider that we test it in a field trial in Telecom Italia, and it is faster than sending an alarm and recompute a reconfiguration.
Another comment before you continue. This is just the technology-specific extensions of a generalized work that is done in NetMod.
Yeah, I
Probably
heard that. Yeah,
these comments needs to go to NetMod.
No, I'm saying that basically I just want to see the actual use cases for this particular augmentation, and I'm not talking. That's a different conversation with that I had with Lou and Ken. That's a different situation, okay? But this is basically, it's kind of a policy that you impose on the device, okay? It's a flexible policy defined by the client and implemented by the server. It assumes that there is for example, there is like an environment, scripting environment on the RODMs, and not all of them have such thing, right? And basically, in case of, say, protection or restoration, it is better to have it hard logic configured, like saying, this is my restoration parameters, and this is what I want to do by configuring and having the server to implement this logic, rather than to provide script and making the same thing but slower.
Okay. Not taken. Let's.
I would think that time's out. I would kindly suggest let's discuss on the list. Okay. Oh. Yes. Okay. Yeah. Thank you. Okay. Thank you. Yeah.
And thanks a lot to Blue, Brown, and Orange for taking the notes.